Hey guys, so what I'm going to cover today is chapter 32, endocrine system. Endocrine system is really important, especially for those of you that are thinking about going into medicine, because the basis of so many diseases is a dysregulation of the endocrine system. So I'm going to go over some specific hormones, some specific glands. I want to talk about negative feedback as it pertains to glucose regulation. And then I'm going to end with a little bit of a discussion on diabetes and tell you what I would like for you to do for your research for your disease, which is attached to this email. All right, so for yesterday's assignment, I just wanted to go over this really quick. Shout out to Mia. This is Mia's little paragraph right here. Said that Goosebumps had evolved. Well, first of all, some of you were kind of picking out the wording saying Goosebumps didn't evolve, the animal evolved or we evolved, which actually is correct. But it talked about how we had Goosebumps, our ancestor had Goosebumps so that the hair stood up so that they would be a little bit more intimidating to enemies, I guess. But when I do the research on it, you're most likely going to find that they're there to make the hair stand up so that the animal can be warm in cold environments. So that was the correction I was looking for. Obviously, you didn't get penalized for that if you didn't put that, but that's what I was looking for. All right, I'm going to talk about some specific hormones. I'm going to talk about the action of some hormones, some cell signaling information, a little bit about positive and negative feedback, and like I said, I'll end with a little bit on diabetes. So I just want to make sure that you guys understand that there's different types of signaling or cell signaling within a cell. Obviously, if it's cell signaling, it's within a cell. We're going to talk about endocrine signaling today, which is when a hormone gets released into the bloodstream. It's slow acting, long lasting, and the signal getting sent in the blood is going to reach a target cell and then have its action there. We also have something called paracrine signaling. Paracrine signaling just means a cell is going to act on a target or multiple target cells around them. Autocrine signaling is when a cell is going to release a signal, and it's probably going, paracrine and autocrine go together. A cell's going to release a chemical. The chemical is going to go to other cells, but then it's also going to loop back around and it's going to signal itself. This is just going to amplify that response. An example of this would be growth hormone. When a cell is signaling other cells around it to grow and divide, it's going to amplify its own growth and cell division by having its signal loop back around. We talked about synaptic signaling, neurons synapsing with other neurons or neurons synapsing with other cells. Our example that we used in class was the motor neuron synapsing with the muscle fibers, causing muscle contraction. And then we have neuroendocrine signaling. This means that a neuron, something from the brain, is going to synapse with something involved in the endocrine system. All right, just a few vocab words here. We talked about this one, what the endocrine system involves, hormones, which are signals that are going to travel through the blood, slow acting, long lasting. Endocrine glands are going to be your ductless glands that are going to secrete hormones directly into body fluids. Examples are going to be the thyroid, the pancreas, the pineal gland, all of those things. And then we have a nice little chart coming up where a lot of those are listed out for you. The hormones are going to be the chemical signals that are released from the glands. Chemical signal hormones can affect one tissue, a few tissue, or most tissues. I will talk about how epinephrine is going to have an effect on multiple tissues. And you can have hormones that are going to act as tropic hormones. That means one gland is going to release the hormone. That hormone is going to go to another gland and cause that gland to release a different hormone. An example would be with the regulation of the thyroid. A hormone is called TSH is going to be released from the pituitary gland, and it's going to go to the thyroid and cause the thyroid to release hormones called T3 and T4. And the thyroid hormones that are responsible for heart rates, they have an effect on heart rate, on metabolism, on body temperature, and lots of things like that. And then we have our positive and negative feedback, which I talked about in the last lecture. Positive feedback is more gets you more. Negative feedback is less gets you more and more gets you less. It's bringing it back to a steady state. And we talked about how homeostasis was actually an example of negative feedback. Right here I have just a chart of 3 different types of chemical signals. Pheromones are chemical signals given off between 2 individuals. Let's say a queen bee gives off a pheromone for workers to go get pollen, and they're going to do what she says based on that chemical signal. So between two individuals. Local regulators are chemical signals that are going to occur short distance between two different cells. And then you have your hormones, which are going to travel long distances. And this is the one that we're going to focus on today. Right, this just shows you a diagram of all of the different glands, how they're scattered throughout the body. Hypothalamus, well, they're all important, but I'm going to touch on a little bit hypothalamus and pituitary. I'm going to talk about the thyroid a little bit, the adrenal glands, and the pancreas. Unfortunately, we aren't going to talk about ovaries and testes because this isn't a reproduction chapter. Maybe we'll get there at some point this year, although it's not in our curriculum, but I can do that if y'all want to. But these are just the really important glands and where they're located in the body. Hormones can either be peptides or steroids, and it's really important to know that there are different characteristics for each one of these. So I think on your note-taking guide, you're going to need to jot down a lot of this information if you're choosing to actually take notes on the note-taking guide. Peptide hormones are going to be peptide and protein go together, right? And so we know that peptides have a chemical structure, and they're made up of atoms that cause them to be polar. And because they're polar, they're going to be hydrophilic. And because they're hydrophilic, they cannot pass the plasma membrane. And if they can't cross the plasma membrane, they're going to require a receptor that is embedded in the plasma membrane in order for them to have an action on that cell. All right? These are going to cause a rapid response. They're short-lived, and here are examples: oxytocin, insulin, and epinephrine. And I'm going to talk about each one of these today. Steroid hormones, remember steroids are like those four fused rings, and they are hydrocarbons. And if they're hydrocarbons, that means that they're non-polar. And if they're non-polar, that means that they're hydrophobic. And if they're hydrophobic, they can cross the cell membrane easily and bind to intracellular receptors. These are going to cause a change in gene expression. They have a slower response. They're longer lived. They can be stored in the fat because they're hydrophobic. And our example for steroid hormones are the sex hormones, testosterone, estrogen and progesterone, and then the stress hormone, cortisol. I am going to focus today on peptide hormones. This just gives you a visual for what I just said. The peptide hormones are going to be released by a secretory cell. They are going to go into the bloodstream. They're going to require a membrane receptor in order to have a response on the cell. Steroid hormones are going to be released. They're going to go through the blood. They pass right through the membrane, have no problem, and they're going to dock onto, and they pass through the membrane of the nucleus too, and they're going to dock onto a receptor most likely inside of the nucleus and have a response in gene regulation. So these are going to be mostly your sex hormones that are going to do that. Just a little review of cell communication, because hormones are obviously involved in cell communication, and the endocrine system cannot work unless a hormone is going to bind to a receptor. We have an amplification of the response, and then we have an activation of a cellular response. So I just wanted to remind you of the 3 steps of cell communication: reception, transduction, response. A hormone, this is something important to jot down, a hormone can have an effect on different types of tissues. However, the response on each one of those tissues will be different because each one of those tissues has a different kind of receptor and a different transduction pathway. For example, epinephrine is going to act on different types of tissues, and each type of tissue is going to have a different type of receptor and a different type of phosphorylation cascade, also known as transduction. So I just kind of wanted you to remember the phosphorylation cascade is going to cause the amplification of a response, and it's actually going to lead to the cellular response. So if a type of tissue has a different type of phosphorylation cascade, a different type of transduction, it's going to lead to a different response. So let me give you the example. Yes, here we go. Epinephrine is a hormone that's released from the adrenal glands that are on top of the kidneys. It is a peptide hormone, which means that it's hydrophilic, which means that it requires a receptor that's going to be embedded in the cell membrane. Here we have liver, skeletal muscle blood vessels, and intestine blood vessels. Epinephrine is going to act on all 3 of these tissues. liver, skeletal muscle blood vessel, intestine blood vessel. It's also going to act on the heart and cause the heart to beat faster, but this is what we're going to focus on right now. I want you to notice that each one of these types of tissues has a different type of receptor. And depending on the type of receptor, you're going to get a different type of response. Depending on the transduction pathway, you're going to get a different type of response. So with epinephrine, which is a fight or flight hormone, it's going to be activated when you're in a situation like taking a test, which you're not having to do right now. I mean, there we go. The silver lining. I was asking the people that came to our little butterfly party the other day, what's the silver lining in all of this? You are not taking actual tests or quizzes without notes. There we go. I know you would rather be in school doing that right now. I know that doesn't make it better. But anyway, you won't have the activation of epinephrine anytime soon, probably. So if I was getting chased, let's say I'm getting chased by a lion. Epinephrine is going to be released from the adrenal glands. It's going to activate the liver cells. If I'm being chased by a lion, I need energy so that I can run or I can fight the lion. I don't think I would fight the lion. I'm pretty sure I would run. So in order to have energy, ATP, we need to do cellular respiration. And in order to do cellular respiration, I'm going to need glucose. And in order to get glucose, epinephrine is going to activate liver cells that are storing glycogen. Remember, glycogen is made up of long chains of glucose. So it's going to mobilize the glucose that is stored as glycogen in the liver so that ATP can get made so that a person or a whatever has energy to fight or to run. Epinephrine is going to act on the skeletal muscle blood vessels because in order to do cellular respiration and to make ATP, the skeletal muscles need, what do the skeletal muscles need in order to do cellular respiration? Yes, you're right. They need oxygen. In order to get oxygen, they need blood. So the skeletal muscles blood vessels are going to dilate. And so more blood is going to rush to the skeletal muscles, so they'll have more oxygen to do cellular respiration to make more ATP so that the individual can run or fight. Epinephrine is also going to act on the intestinal blood vessels, which is interesting. The intestinal blood vessels are going to constrict, not get as much blood flow. And so I'd asked you why. If we were staying in class, I'd be like, why is it that we are limiting blood flow to the intestines in this situation, in this fight or flight situation? And I know somebody would get the answer. It would be, well, intestines are not a priority. Digesting food is not a priority when you're in a fight or flight situation. And so the body is basically going to shunt all of the blood to the skeletal muscles and take blood away from the intestinal muscles. It's like, hold on, we don't need to digest food right now. We're just going to go straight to the liver and get glucose from there. We're going to supply the skeletal muscles with blood and oxygen, and we're going to run or we're going to fight. This is the reason why whenever you have a fight or flight response, when something's happening, like you're taking a test or, I don't know, you're about to ask somebody on a date, I don't even know. This is why your stomach hurts whenever you have a really bad anxiety and a really bad fight or flight response to a situation that may not require a fight or flight response. But that's why when little kids, when they say, my stomach hurts, a lot of times if you have a child, so you'll remember this later when you have kids, when your child says my stomach hurts, it's usually not that they're having intestinal issues per se. They're having some kind of psychological issue where they're scared of something. So just a little pearl of wisdom right there. Right? And there's your information. You can pause if you need to right now. That's going to say blood vessels to intestines constrict. That's going to say blood vessels to intestines constrict. All right. The hypothalamus. So I'm going to talk about some of the glands. We start with the hypothalamus. The hypothalamus is going to be our master gland that's going to regulate everything else. The hypothalamus is going to activate its buddy, the pituitary gland. And the pituitary gland has two parts, the posterior and the anterior. And so where you're going to have your neuroendocrine synapsing is involved in this place right here. So you have the brain with the hypothalamus. Where's the hypothalamus? Sorry, the hypothalamus and then the pituitary right underneath it. All right, so the hypothalamus is going to receive information from nerves. So there's going to be a neuron that's going to synapse with the hypothalamus, and it is going to initiate the endocrine signals. That's what makes it the master gland. So the pituitary gland has two parts. The posterior pituitary gland is going to have oxytocin and antidiuretic hormone. Those are just two examples of hormones that are going to be released. Oxytocin is a really interesting hormone to me because this is called the love and bonding hormone. Oh, I'm trying to make a heart. There we go. The love and bonding hormone. It's the hormone that is released when you fall in love. And it's a hormone that's released when a mother is breastfeeding her baby and she feels the bonding. Oxytocin is literally responsible for lactation and labor, which is why it's so important for a mother to have the baby on her right after she has it, because it creates a bonding between mother and child, which is going to be beneficial throughout the rest of your life. It's also involved in love and bonding between two people. This is called the hugging hormone. It's the hormone that's released when you hug someone. So something kind of interesting about oxytocin. I used to work at this pharmacy. It was a compounding pharmacy. And so we would make all this weird stuff. But one of the things I remember making was oxytocin candies. And they were these little red candies that we would make, and we would sell it to people like, hey, if you're going on a date, you and your date need to take these oxytocin candies and eat them. And the oxytocin hormone is not something that is really regulated per se. I would call it more of like a supplement. And so they let me take some of them home, some of the little candies home. And I'm going to just tell you that it didn't work. And the reason why it doesn't work to ingest hormones. Like, oh, well, if someone's they don't have enough insulin, why don't they just eat some insulin? Your stomach is going to degrade anything, any kind of hormone, any kind of chemical that you put into it. So if you eat oxytocin candies, which I don't even think this pharmacy that I worked at is in business anymore. They were so shady. If you eat oxytocin candies, the actual oxytocin protein is going to get degraded in your stomach. It will never enter your bloodstream in the first place. So I just thought that was something kind of interesting that I always tell students every year about my little oxytocin candy experience, which really fell flat. All right, the anterior pituitary is going to release two hormones, follicle stimulating hormone and luteinizing hormone. These are going to be involved in ovulation. So follicle stimulating hormone is going to get the ovary ready to ovulate. Luteinizing hormone is going to cause the egg to pop out. And that's going to happen on day 14. So day 1 of a woman's cycle is the day she starts her period. Yeah. Day 14, day 13 or 14 is the day that an egg is going to be released. So a lot of women, especially when they're trying to conceive, they're going to chart their menstrual cycle. And so they can actually chart and they can actually test when luteinizing hormone. So luteinizing hormone shoots up, and then the next day she ovulates. And so a lot of women that are trying to conceive will have these test kits. And I know I'm giving you guys a lot of information, but I think this is interesting stuff. So I am going to let this lecture go on a little bit longer. If you need a break, then just push pause. But a lot of women can get these test kits where they have this stick. And so you pee on this stick and then you stick it into this machine. And the machine reads how much luteinizing hormone is in your urine, because it gets expelled into the urine whenever a woman is producing it from her pituitary gland, because it circulates through the blood. And then eventually the kidneys are like, oh, you're not using this. And it takes it and it puts it into the urine. And so this machine that you put that little stick into is going to measure how much luteinizing hormone is in your urine. And it can actually tell a woman when she's going to ovulate and when she's going to be able to conceive. So I think that's pretty interesting. Next slide. All right. This is a really big chart. You're not expected to memorize any of this. I'd like for you to be familiar with just some of the interesting hormones like oxytocin. You're never going to forget my story about the oxytocin candies. Antidiuretic hormone is one I want to bring your attention to. This one's really important. Antidiuretic. So you know a diuretic. At this point in time in your life, you should have heard that if something is a diuretic, if something causes you to diurese, it's going to cause you to urinate. So we hear a lot, caffeine's a diuretic. So if you're dehydrated, don't drink caffeine because it's going to cause you to urinate more. So if something's an antidiuretic, it's going to cause you to urinate less. And where does the water come from? So the water in your urine is coming from your blood, right? So if you are urinating a lot, your blood volume is getting lower, and therefore your blood pressure is getting lower. So that's why if a person has high blood pressure, they're going to take drugs that cause them to urinate more so that the blood volume goes down and so their blood pressure goes down. So that kind of drug would be a diuretic drug. Antidiuretic hormone is going to do the exact opposite. It's going to keep blood volume high, it's going to reduce urination, and it's going to make sure that there is enough blood being provided to the organs by increasing blood pressure. So if there's anything that you need to remember about antidiuretic hormone is pee less, blood pressure more. So when would this be important? This would be important when a person gets into something like a car accident and they start bleeding out. If a person is bleeding out, their organs are not getting enough blood, therefore antidiuretic hormone is going to kick in, turn the kidneys off, and is going to do everything it can to keep that blood volume up so that the organs can get enough blood so the person can survive. Obviously, when a person has high blood pressure, this hormone potentially is going out of whack. All right, so a person is just chilling at home, they're not bleeding, antidiuretic hormone kicks in, and it's like, okay, blood pressure goes up, they probably will experience something like a headache, and we know that high blood pressure is dangerous because it could cause a person to have a stroke, and it's just dangerous. So a person with high blood pressure is going to take a drug that's going to counteract the actions of antidiuretic hormone. The other hormone that's interesting is prolactin. Prolactin is a hormone that's released from the anterior pituitary, and it's a protein. All of these are proteins, so all of these require a membrane receptor. It's going to stimulate milk production for a woman who's lactating. I already talked about FSH and LH. Thyroid stimulating hormone is called TSH. This is one of the things that is going to be tested if a person is having issues with their thyroid. TSH is released from the pituitary and goes directly to the thyroid to release thyroid hormone. So TSH would be an example of a tropic hormone. So when a person is hypothyroid, that means that they are not releasing enough T3 and T4. And so the symptoms of hypothyroid, I am not going to tell you the symptoms of hypothyroid because somebody is going to tell us on our Zoom tomorrow. Stay tuned. All right, the pancreas is going to release two hormones called insulin and glucagon. I'm going to go over those in a minute. The adrenal gland is going to release epinephrine. I've already gone over those. And then the other one that I'm not going to ask, I don't think I ask you a question on it doesn't matter if I do, it's an open note quiz, so it doesn't matter. The pineal gland is going to release melatonin, and those of you that you can just buy melatonin over the counter at like CVS or Walgreens or a grocery store or something like that. Melatonin is a hormone that is released when the sun starts going down. It's going to stimulate your brain to tell you, I'm sleepy, I want to go to sleep. If you have problems with insomnia, you can just, this is actually an example of a hormone that your stomach doesn't degrade. So I take back what I said a minute ago. You can actually eat melatonin and it will work on your brain to make you think that the sun's going down, so it'll make you sleepy and help you sleep. If any of you have ever taken melatonin, the biggest complaint about it, at least when you first start taking it, is that you have crazy vivid dreams. Crazy. They're not scary, they're just really vivid and almost real-like. So just something interesting about that. All right, our negative and positive feedback. So negative feedback systems are going to involve your thyroid hormone and blood glucose. Your positive feedback systems are going to involve labor and lactation, like we already talked about. All right, this is very, very important. Blood glucose regulation is very, very important. A lot of people, especially in America, have diabetes, and this is something that if anyone's thinking about becoming a nurse, pharmacist, doctor, you are going to need to know this, especially if you're going to go into endocrinology, which is a great practice to go into, endocrinology. Normal level. So here, let's kind of look at the middle. This is our set point. Blood glucose needs to be between 70 and 110 milligrams per 100 milliliters. That's our set point. That is what we want at all times. So let's kind of follow this chart, follow my cursor here. All right. So I am going to eat a big piece of cake. Okay. Where'd my cursor go? I'm going to eat a really big piece of cake. That's the stimulus. So when I eat a big piece of cake, it's going to be digested and a bunch of glucose is going to be spilled into my bloodstream. My body is going to sense that my blood glucose levels have risen, and my pancreas is going to be stimulated to release insulin. Once insulin is released, insulin is going to do two things. It's going to act on body cells to take up more glucose and to perform cellular respiration to make ATP. And then it's going to cause glucose to be taken up into the liver to be stored as glycogen for later use. After those two things, cells take up glucose, liver takes up glucose, blood glucose goes down. I'm now at a normal level. All right. When I decide that I've eaten so much cake and the scale starts going up and I get really depressed, I'm like, I'm going to do it this time. I'm going to do it. I'm going to go on a keto diet and I'm going to lose weight. And it's going to work. If you guys knew how many times I've done that, it's sad. So I start on my keto diet journey and I start getting really hungry. And my blood glucose levels start to go down below that 70 to 110 range. And when they go down, they are going to stimulate my pancreas to release a hormone called glucagon. Glucagon is then going to stimulate my liver to break up that glycogen. So the last week when I ate all the cake and it got stored as glycogen, glucagon goes to the liver and is like, yep, she's doing it again. She's on the keto diet again. Let's just go ahead and release this stored glucose, make her blood sugar go up. This is when you start getting that nauseous feeling when you're really hungry and you feel it almost down in your liver area. That is your liver saying, hey, you haven't eaten enough. We're about to use all of our reserves and you're about to starve. This is also the point where you start getting very hangry. And a person is going to get hangry and really irritable because we have evolved to get very angry and irritable at this point, because if we're angry and we're irritable, we are going to be more successful in hunting and killing that wild boar and wrestling it and biting it in the jugular. I know I'm being like super exaggerating here, but this is what we're animals and this is what we've evolved to do. So that's when you're going to get really hangry. Your blood glucose levels are going to go to normal at that point once all the glucose gets released from the liver. But at some point, you're probably going to need to eat some carbs again to make that work. All right, so hopefully y'all understand that. This is just giving you another visual for what I just talked about. All right, so let me talk about diabetes for a minute, and I think I'm going to make it at just 30 minutes. We're almost done. So diabetes is a dysregulation of the pathway involved in glucose regulation. So a person with diabetes is going to have a lot of glucose in their blood. So what's the problem with that? They are going to have a lot of glucose in their blood for two reasons. So I'm going to talk about the problems in just a second. So two reasons: type 1 diabetes or type 2. Type 1 diabetes is only going to incorporate about 10% of the people that have diabetes. And this is also known as juvenile onset diabetes. And what's going to happen is that this person is going to have an autoimmune disorder. Autoimmune. What does that mean? Does anyone remember what that means? Autoimmune means the immune system is going to attack self. So the immune system, for whatever reason, is going to be stimulated to attack the pancreas and is going to destroy the pancreas cells that make insulin. Therefore, the person isn't going to have enough insulin. Therefore, let me go back to my chart. Therefore, this is not going to happen. And this is not going to happen. So their blood glucose is going to be too high. All right. Let me go back. Okay. So how do you treat someone with type 1 diabetes? It's actually really easy to treat, which is why you don't hear about these people very often. You just give them insulin and you give them a schedule of insulin and you put them on a consistent diet where they're getting consistent amounts of glucose every day. They do still have to check their blood glucose and all of that stuff, but this one is a lot easier to treat than this one. So type 2 diabetes are the people that you hear about the most that just cannot get under control. 90% of people with diabetes are going to have this. Type 2 diabetes is mostly going to occur in the 40s or 50s. It's going to be a result of just a really, okay, there is a genetic component to it. I can't leave that out. But it's a genetic predisposition coupled with really poor lifestyle. Those two need to occur together. So this person is going to be fine until they're not, all right, up until the 40s and 50s. And usually this is the person that's eating donuts, Cheetos, McDonald's, just horrible, horrible eating habits consistently over time. And finally, the cells just start to say, dude, we're not going to respond to insulin anymore. Insulin comes knocking on the door of the cell like, hey, I got some glucose here for you so you can do cellular respiration. And there's something about the source that it comes from that just makes it, glucose is glucose, but somewhere along the way, the body senses the glucose is coming from this orange powdery, snack that this person is eating. I no longer want that person to feed me this. So therefore, when insulin comes knocking, I'm not going to answer the door, not going to let glucose come in because I no longer want to get it from these sources. And then the cells end up just being completely resistant to insulin. Like, nope, not going to take glucose anymore. Sorry. And so therefore, if the cells don't take in glucose, if the liver is no longer able to store glycogen as efficiently, the blood glucose levels are going to be high. So what is the problem with high blood glucose levels? Well, first of all, the person's going to be constantly hungry. They're going to be really thirsty because if you have a bunch of glucose in your blood, you'll end up peeing out a bunch of glucose, and water follows sugar, as we've learned in our previous lessons and lectures. So back in the day, whenever the doctors used to test for glucose, they would have a person pee in a cup, and then they would take a sip of it. And if it tasted sweet, that means that the person had diabetes. We no longer have to do that because we have blood tests, but literally sugar gets spilled out into the blood. And the other problem with diabetes and with having high glucose levels in the blood is that glucose crystallizes, right? It can crystallize and cause like a little crystallized structure, and it's going to clog up the very small blood vessels in the extremities. So this is why you hear about people with diabetes having to get their feet cut off, because glucose has literally obstructed blood flow to their feet. And they're more prone to infection and all of that stuff. So just a really, really bad deal. This is what I'm going to have you do. This is my example of your disease research. So if you look at the document attached to the email, you will get your own disease. Some of the diseases are repeated among people because I just could not find enough endocrine diseases that were interesting enough. So if you have another person that has the same disease, still do it on your own. I'm not going to call on everyone in our Zoom meeting tomorrow, but just so you know, this is the example of how I want you to present it. Short, to the point, 2 minutes or less is how I'd like for you to present it. If you have any trouble with this, please email me and I can help you out with it. And then go ahead and go to Socrative for a concept check on this lecture. Same room number as before. For your disease, if you can write down your research on a piece of paper, go ahead and write it down on a piece of paper, have it ready for our Zoom meeting tomorrow. Please come to the Zoom meeting on time. If I call on you, that gives you your credit for that assignment. If I don't call on you, you're going to take a picture and you're going to send it to me through email tomorrow. So don't worry about that tomorrow. So sorry this went a lot longer than my other videos. I just love talking about the endocrine system, and I feel like I had some interesting things to say about it. So hopefully you watched it all the way through and that you got something from it. All right, I will see you guys in our Zoom meeting tomorrow. Hope you're having a good day. Bye.